Okay, this is the explanation for the questions inside the slide. So I'm going to go through the questions and examples for you to understand how it works. So we just recap back on the definitions of the clock and the instructions. Here you can see that we have two terms that we need to understand, which is the first one, they call it the clock cycle here, and the second one they call it the instruction cycle. So these two terms is related. These two terms are related to each other. So you need to understand first what is a clock cycle, right? So the clock cycle is the time for one oscillation of the clock. So for example, here your clock will be like this. This is your clock oscillating. So the full, okay, for one oscillation, full oscillation would be from the first here up to this one. So this is a full oscillation. One full oscillation. So it's the same like the process here. You can see that if you have the oscillator which is oscillating, is constantly oscillating, right, by a standard uniform wave over here. This is a square wave. So every time it goes up and goes down, there is actually one cycle of clock, one oscillation. So this is one oscillation here. So the clock cycle is this one. Okay, so what is instruction cycle? So instruction cycle is the cycle time for one execution. So one execution of instruction, one execution of instruction is an instruction cycle. So the time needed, which is the total of 4 clock cycles. So instruction cycle is actually 4 clock cycle. This is considered one instruction. So this is considered one instruction cycle. So this is not for instruction. This is actually going to be 4 clock cycle. Right. So this is 4 clock cycle, which is going to be one instruction cycle. Okay. So this clock is based on the clock that you give to them, because for example that your crystal, this is what we write down in crystal, right? So for example it's 20 megahertz, which is commonly used for the PIC. So the tempo, okay, the tempo would be 1 over t is equivalent to frequency, right? So the t is equivalent to 1 over f. So you can see that this one is going to be t is 1 over 20 megahertz is equivalent to what? So you can use your calculator. 20 megahertz, right? So 1 divided by 20. Mega means 60. 1, 2, 3, 4, 5, 6. This is equivalent to 5, 10, negative 8, which is equivalence to what? This is going to be equivalence in engineering. You can go back to engineering. This is a 50, negative 9. This is going to be 50 times 10 to negative 9. This is equivalent to 50 nanoseconds. So this is the clock cycle, but I'm going to show you this one after this in the example. Okay, let's look at the example here. The example is asking you the clock and the instruction cycle. So given a microcontroller with a 20 megahertz crystal, so crystal, you can remember that this is what basically. So I'm going to give the image over here back. Okay. So this is the one. The crystal is this one. This is the crystal. So you have to put this one. This crystal will be connected to the clock 1 and clock 2 pins. If you can go back to the pins, you can remember that you can see that these 2 pins must be connected to the clock. So this clock is important because this clock will provide you the signal for the clock signal. Alright, so this is a clock. So given a microcontroller with a 20 megahertz crystal, so this value is 20 megahertz. Example, calculate the time for one instruction cycle. Remember that one instruction cycle is actually going to be a 4 clock cycle, right? So one clock cycle is equivalent to one tempo lah. Tempo is equivalent to 1 over f, which is this frequency. Okay, let's try to look at this one. The question is calculate the time for one instruction cycle. So you have to find the clock cycle first, and then you have to times 4. The first one, the oscillator over here, given 20 megahertz, and one clock cycle is equivalent to 1 over f is the tempo. So this is the value here. So if you can go back to the calculator again, this is the same example just now. 1 over 20 megahertz is equivalent to 5 to the power negative 0.8, right? So this is going to be a prefix metric. So if you cannot remember that, this is the table that we are going to use for this particular prefix. Okay, so for example here, this is 5 to the negative 5 times 10 to the negative 8. There's no negative 8 over here, but doesn't matter at the moment. So you can see that now you are going to calculate the instruction cycle, which is 4 of them. So based on this particular one clock cycle, you times 4, then you can get 2 to the power negative 7. Negative 7 still not here, but you can try to click the engineering button over here, which is 200 negative 9. So negative 9 is where? Negative 9 is this one. So this is correct. So this is nano. So this is going to be 200 nanoseconds. So this is going to be a 200 nanoseconds. If you cannot remember the prefix, you can refer to this table. Alright, so that is the questions of getting the one instruction cycle based on the 20 megahertz crystal. So let's try another question over here. I'm going to remove out this one first. The next question is get the instruction cycle, same one instruction cycle, for a microcontroller with 8 megahertz clock. So this clock is different from this one. So you can try. For the first question is, this one is 8 megahertz. The crystal is given 8 megahertz clock, right? So the clock cycle will be 1 over 8 megahertz. This is equivalent to 1 over 8 megahertz. This is 1.25. Okay, 1.25 times 10 to the negative 7. This is only clock cycle, but the question asks to get the instruction cycle. So you know that to get this one, you have to times 4 to get the answer. So the answer just now, you just times 4, and that is the answer. It's equivalent to 5 times 10 to the negative 7. So negative 7, you can just simply put this answer, doesn't matter because this is a standard one. But if you want to use the prefix matrix, then you can find out from here negative 7 is not here, so you can just use engineering button here. 500 negative 9. 500 negative 9 is what is a nano, so this is going to be a 500 nanoseconds. Or this is the answer, but my answer now is in micro, right? Micro means you can shift engineering. This is 0.5 negative 6. 0.5 negative 6, this is going to be this one micro. So 0.5 is equivalent to 0.5 microseconds. Just to make sure that you guys do not confuse with the matrix. with the number over here. Alright, so this is the answer. This is the correct one. Okay, the second example is, let's read the question first. Okay, given one instruction cycle of a PIC is 0.4 microseconds per instruction cycle. So the question is given that the instruction cycle is given with this value, alright, is per instruction cycle. So the question asks, what is the crystal given? Just now the first question, crystal is given. Crystals is given, the first one. And then you need to find the instruction cycle. This is question. But now, this question, the second question is, you are given the instruction cycle is here, and then you need to find what is the crystal. So it's kind of a reverse engineering or reverse method. You need to find this one first, and then you can find what is the value for the crystal. So it should be the same one. It's just a mathematics, but you need to just go back from the answers and go back to get the crystal value. So the formula for the instruction cycle is 4 times clock cycle. This is the first one, clock cycle, right? Is equivalent to 0.4 microseconds. Alright, 0.4 microseconds means that 0.4 microseconds is this one, -6. Alright. So microseconds is over here, right? So this is the 1 microseconds. So you can choose shift. If I'm not mistaken, you can use shift 0.4 shift micro. So this is one. It's okay. And then you can find this from this one. You can know that the clock cycle is equivalent to 0.4 microseconds divided by 4. That is the clock cycle. So you can try to use your calculator. 0.4, okay, micro is here. This is micro. Divide by 4. That is the equivalence of the value for the clock cycle. So 1 to the -0.7 is not here, right? So you need to know what is the value that you can use. So let's look at engineering here. This is 100 -9. -9 is -9 is this one is nano. So this is equivalent to 100 nanoseconds. Okay, this is clock cycles at seconds. 100 nanoseconds. Okay, so you have the answer for the clock cycle. So remember that the clock cycle, okay, the clock cycle is equivalent to 1 over f. This is the questions. This is the one that you need to find, because you need to find the crystal clock, the frequency of the crystal clock. So 100 nanoseconds equivalent to 1 over f. So f is equivalent to 100 nanoseconds. So you can use this one, the same value here, 1 divided by answer just now, right? So the answer will be this one. Then you need to know this is how many already. So this is going to be engineering. Let's try to put engineering here. 10 to the power -6, 10 to the power 6, 10 to the power 6 is here. So this is mega. So 10 mega, which is 10 megahertz. The answer is 10 megahertz. Okay, so that is the method on calculation, how you want to calculate this clock instruction cycle. All right, let's go for the quiz later then. Thank you.